We're going to talk a bit about the Weather Service, some of the things we do here, and then after this we'll go out in our operations. I'll give you a quick 5-minute tour. I mean, it's one room. It's not really a tour. It's just look around the room. And then we'll go up the hill at 5 and do the weather balloon launch. And we'll try to get it as close to 5 as we can, because it's almost dark at 5. You won't be able to see much, but you can see some, but it's not like when we do these during the summer when it's daylight forever. All right, who are we? The National Weather Service. We're a federal agency. Let me grab my water. I'm gonna need this. It's my second talk today. I went out early and I got one here. We're a federal agency under the U.S. Department of Commerce, a branch of NOAA, which stands for National Oceanic and Atmospheric Administration. That's our parent agency. That's where we get the term NOAA Weather Radio. We operate 122 field offices just like this one around the country, plus several centers, which I'll get to those in just a second. Our annual budget's a little over $1 billion, which comes out to about $3 per U.S. citizen per year. We have about 4,800 employees nationwide. There's a map of the Weather Service, all of the individual offices and our county warning areas is what we call them. In addition to the local forecast offices like this, we operate several specialized centers. The Storm Prediction Center and the National Hurricane Center are probably our two best known, but there are others, lesser known specialized centers that we interact with on a regular basis. So who are we? We are not the meteorologist you see on TV every day. Every time somebody asks me, I mean every time, what do you do, Mark? I'm a meteorologist. Oh, what TV station do you work for? And it never fails. I have to explain, I don't work for a TV station, I work for the National Weather Service. We are responsible for making forecasts and issuing severe weather watches and warnings. We're the only entity authorized to issue severe weather watches and warnings, which we'll talk about those in a little bit and more in depth. In addition to the warnings and watches and forecasts, we monitor rivers around Middle Tennessee, like the Cumberland River, the Duck River, the Elk River, the Buffalo River, and some other rivers and creeks and streams and various tributaries around Middle Tennessee. We do have a full-time service hydrologist that does nothing but rivers and flooding. We generate the computer atmospheric models that we use to forecast, also the private sector uses. We produce aviation forecasts for airports, fire weather forecasts for the forestry people, monitor tropical cyclones, and generate long-term climate predictions. When fully staffed, there are 23 of us, but we are not fully staffed. There are only 20 of us right now. Most of us are meteorologists, as you might guess, since we are a weather offices, that would be important. But we also have, again, the service hydrologist. We have some computer people, electronics people, an administrative assistant, a management staff. There are usually at least 2 meteorologists here on staff at all times. Now, sometimes it'll go down to 1 when the weather's nice, like tonight. We can flex our hours, telework. We've got 1 teleworking tonight, doing operations from home. We have figured the pandemic.
So Mark,
yes.
How big is National Weather Service compared to the NOAA? What else does
We're
NOAA
tiny.
Okay, what else does NOAA do?
There's the fisheries, there's NESDIS, the National something, Satellite something something.
Okay.
And there are other, and we're not all weather either. It's a lot of ocean stuff, and there are several sub-agencies under NOAA. We're tiny, we're minuscule as far as federal agencies.
You're still $1 billion agency.
We're still $1 billion. $1 billion to the federal government's nothing.
That's a toilet seat.
Exactly. Again, I mean, $3 per U.S. citizen, out of all the taxes you pay, just $3 of that goes to the Weather Service. So.
That is a deal.
That is. I'm glad you said I like it. Yes.
So what exactly is a meteorologist? Do you have a special degree?
We do. We have a degree in meteorology or a related field like atmospheric sciences. My degree is in earth science with a concentration in meteorology. So, but there's a degree that comes with it, and then there are certain qualifications you have to meet in the National Weather Service to be considered a meteorologist. And it's, the private sector may have their own qualifications as well. We're not the only employer of meteorologists, obviously, but it starts with the degree. We work 8-hour shifts typically. We work rotating shifts that change at 7 a.m., 3 p.m., and 11 p.m. most of the time. Again, we're in a position we can flex our hours according to the demands of the weather if need be, but those are the general shift change times. Teleworking from home has become more prevalent since the pandemic. We were not allowed to telework before the pandemic, but we learned how to do a lot of things we've never done before because of the pandemic. So now we're really maximizing our telework opportunities. And again, we can flex our hours during periods of quiet weather in order to make shift work less demanding. And then we're continually experimenting with teleworking and shift flexing in order to address quality of life issues. That's big with the Gen Zers that are coming into the Weather Service now. They're big on quality of life issues. They do not like shift work. And so in order to recruit the kind of talent we need to keep the agency going, we've got to figure out ways to make shift work more appealing and less demanding and less stressful.
Or just up that budget to $2 billion.
I'm sorry?
Or just up the budget to $2 billion.
That's not going to happen anytime.
Obviously, you're
Come
not
into
doing-
work, double it up.
Obviously, you're not doing a very good job with recruitment because there is a key pendant that is missing from that wall.
And which one would that?
That would be the University of Tennessee.
Well, the Tennessee, they don't have a meteorology program. There are, I think there's only one university in the state of Tennessee that has a meteorology program. That's University of Tennessee Martin. We don't have. I've never met anybody. I think it's a kind of a new program, but the closest one to here is Western Kentucky.
What about physics? Doesn't that count?
What's that?
What is that?
Doesn't quite count, unfortunately.
What is physics for 100?
What else do? We do something called Impact-Based Decision Support Services, IDSS, where we go out and support a local emergency operations center during a big event like the CMA Fest every June, Titans games, concerts at Nissan Stadium, county fairs, especially when lightning may be an issue, because if lightning is observed within an 8-mile radius of an event, they have to shelter in place. And so they like having a meteorologist on hand to help them, advise them of if and when that might occur. And so we have started.
We get that for our $3?
You got that for your $3 too? You wouldn't believe what you get for your $3. By the time I'm finished, you'll be amazed.
Right, so the big venues that have these events, they don't pay you a fee.
No, that's where we work in coordination with the local Office of Emergency Management. That's what your $3 goes toward. They don't pay. No, they don't. We don't charge them for that. That's just part of our duties.
So how do we sign up to get those services for all of our regattas?
You would have to. You can't. Again, we work through each county emergency management agency usually. They'll be on site for.
And is it like
events like
based
that.
on populace of an event, or like how?
Based on, well, not necessarily. I mean, we'll go to, if say, let's say one of our smaller counties, like, let's say Marshall County, for example, the Marshall County Fair called up. They said, would you come do this? We would do it if we could, as long as we have the people available. But there's no size limit. If they need us, we go.
Opportunity.
2,000
feet
feet
away.
away. 30-foot metal rods out in the middle of the lake and see how that affects things?
Yeah.
That's some kind of
We're
study.
in Wilson County.
We communicate with media, emergency managers, and other partners via Slack. We have our own Slack channel. Communicate with everybody. We engage in telephone and in-person media interviews. We manage a cooperative program of volunteer observers. We have several dozen weather stations scattered around Middle Tennessee. Some of these go back many decades. We have several towns in Middle Tennessee with decades worth of climatology, where we go set up a weather station in their backyard, or sometimes it's like a water treatment facility or some kind of official organization like that, and they'll report daily high and low temperatures and rainfall and snowfall back to us. So we manage that. We have a person that goes around, checks all the equipment, makes sure everything's up to date and well maintained. We give a weekly webinar, sometimes more often, but at least once a week with the emergency management community, just a weekly weather briefing. But if we're expecting like a big, a severe weather event or a major winter storm. We can do those every day. We just using a GoToWebinar. We are on social media. Every NWS office has a Facebook page, including this one. We currently have a little over 230,000 followers. We have the 5th largest Facebook audience in the Weather Service, which we're very proud of. We work very hard on our social media. And we put out daily forecast graphics, outreach information, like what to expect, spotter classes, things of that nature, frequent severe weather information and updates as the situation demands. It's also an avenue for storm spottings, storm reports, snowfall reports. We get tons of reports, especially during snowfall. It's great. We get all kinds of snowfall measurements. People go out and stick a ruler in their snow and snap a picture and send it to us. We draw up these real detailed snowfall maps doing that way. So great. And then on X, it's Twitter. It'll always be Twitter. It's very similar to a Facebook page, except we're limited by the 240 character thing, so it's not a mirror image, but a lot of the same information we put on Twitter.
So the news stations, are they getting the forecasting and stuff from you guys, or are they doing that independently?
Both. They get all the information that we get. They get all the information that we put out. They do their forecasts independent of us. That's why they don't always match.
Okay, so do you ever look at their accuracy versus yours?
I do not. To be honest, I never watch.
Nate Silver did. He's got a really nice chapter on that.
I never watch the TV weather, so I don't look at I don't know what they're forecasting.
But they
They're
depend on you
the
for the
best.
warnings and
Everybody
everything,
else
right?
Yeah, the warnings that go out are always from us. Even the ones that they show on the television, like they scroll across, those come from us. Those are ours, yes. But as far as the forecast, each TV meteorologist does their own forecast independent. I mean, it's not going to. I don't think we're not going to, differ, wildly or anything like that. But there are subtle differences in the forecast for sure.
Yeah, subtle differences are
Yes.
a wheelhouse.
Yes, I mean it could be. This person says 2 to 4 inches of snow. This person says 3 to 5. This person says 4 to 6. I mean, it's just, yeah. We have a webpage, weather.gov/Nashville. We have a near infinite array of information on there, climatology and forecasts and radar and hydrologic stuff, and a lot of digging around to do. That's our county warning area. We are responsible for 38 counties. Total population, almost 3 million. We cover a little over 16,000 square miles. About 40% of the land area of Tennessee we cover. Go roughly from the Kentucky state line to the Alabama state line, and then from the Tennessee River out west to the Cumberland Plateau in the east. And that on the right is a full-page newspaper spread I dug out of a drawer many years ago while sorting through some old climate records. That is from the Nashville Tennessean on Sunday morning, August 11th, 1929. That's actually hanging up there. We had it framed. And it's when we were located in the Stallman building in downtown Nashville, which the Stallman building is still there. I think it's apartments or condos or something now, but we used to be in there and our equipment was on the roof. We've updated the equipment since then, fortunately, but that's what it looked like back then. Weather radar, we just saw it out there. It does not have a smiley face on it. I have no idea who did that. But we have a Doppler radar network. We have ours here, but this is not the only one we use. We have Doppler radars surrounding Middle Tennessee. There's one at Fort Campbell, and there's one in Huntsville, in our sister office in Morristown, and Memphis also, and we can all pull up each other's radars and look at them and mesh them together and make mosaics and all kinds of neat stuff. That's important because the radar beam, the farther out from the radar it goes, the higher above ground it gets. It doesn't curve with the Earth's curvature, it spreads. So let's say when we send out a pulse of energy here, it's not like straight out, it's half a degree, it's elevated half a degree, and above that too, but the lowest angle is half a degree, so slightly above the horizon. So by the time that radar beam gets over, say, downtown Nashville, it's maybe 700 feet above the ground, or right over the top of the back building. But by the time that radar beam reaches the edge of our county warning area, it may be 8,000 or 9,000 feet above the ground. So we miss anything that happens underneath that. Small spin-up tornadoes, or shallow thunderstorms, things of that nature, we could miss. So it's nice to have other radars. Say if a storm's happening up around Clarksville, we can look at Fort Campbell's radar because it's closer. Or if a storm's happening in, say, Pulaski, we can look at Huntsville's radar because that's closer to the storm. So we look at each other's radars. And
On
not
average, when you do a wind prediction, how far above the lake surface would that be?
just
generally?
100 feet, 200 feet, 300 feet, depending on how far out it is, not very far.
So,
So basically a surface, well, not exactly a surface when it's
we're
close.
relying on wind at, say, 50 feet.
Mm-hmm.
And
The only way you're going to get a surface wind is to have an anemometer at the surface. That's the only way to do it. Otherwise, if you use radar, you're going to be getting winds above the surface. So yeah, not.
The radar's not even giving you wind speed.
No, it's estimating wind velocity. It's not measuring wind speed. It's estimating wind velocity in the atmosphere based on the flow of particles, whatever it's detecting. And if there's no particles, we don't know what the winds are. If it's clear air, then
No idea.
we got nothing to detect. But just by measuring or estimating detecting the movement of cloud particles, raindrops, bugs, birds, anything that will return a radar signal will help us estimate wind velocities. But it's just an estimation again. All right, tornadoes. We have a very extensive tornado database covering Middle Tennessee. We have done quite a bit of research over the years, going back over old newspaper articles back in the 19th century even. The first tornado that we have found hit Nashville in 1811. That's the earliest one in the database. And that's when you plot them all on a map, that's what they look like, all 928 of them. As you can see, most tornado tracks in Middle Tennessee and pretty much anywhere travel from southwest to northeast. Most of them, not always, but most of them travel southwest to northeast. So when we sort tornadoes by month of the year, we find that most of our tornadoes occur during spring, during the months of March, April, and May. That's our tornado season. Obviously, I think it's almost 2/3. I think the figure's like 63% of all our tornadoes occur just during that 3-month period. And then there's a lull after May. When you get into late summer, early autumn, that's a minimum. There's no time of year when we're completely immune to tornadoes. We just came out of that. There's a secondary severe weather season in November, which we're going to get through November without any severe weather outbreaks. Fortunately, we've got some weather coming in next week, but it's not going to be severe, so we managed to escape the secondary severe weather season for 2024, thank goodness. And then when we get back into the late winter and especially the spring, things crank back up.
That's interesting. So January and February,
Then we get January. There can be warm spells in January and February, and we've had some really big tornadoes happen in January and February, believe it or not.
yeah, you would think it would be like kind of seasonal change more than anything, but January and February is usually
Does severity
steady.
correlate with quantity?
Not necessarily.
Are those kind of edge months? I guess you're looking at temperature differentials and the amount of energy being introduced into the atmosphere.
Yeah, it's based on your instability, how quickly the air rises, and your wind shear, which the highest wind shear does happen during the late winter and spring, so you get most of your wind shear then. But you can get some really, strong tornadoes even outside the primary tornado season.
So the bulk of our regattas need to be March, April, and May.
We have this thing called the enhanced Fujita scale, which is how we rate tornadoes. Used to be called the Fujita scale, developed by a professor named Theodore Fujita at the University of Chicago. He did quite a bit of really groundbreaking research into severe storms and tornadoes, and he developed the EF scale, the F scale, originally in 1971. Just took the first letter of his last name and put a number with it, and got F0 to F5. We came up with the enhanced Fujita scale in 2007, not to replace the F scale, just to improve upon it, just based on various engineering studies and other things that we had learned since the original Fujita scale came out. So that's where the EF comes from, enhanced Fujita scale. Goes from EF0, weakest, EF5, strongest. There's only been one EF5 in our county warning area. In fact, only one that's ever hit the state of Tennessee. And that happened in Lawrence County back on April 16th of 1998. That's the only EF5 in Tennessee's history. That occurred on the same day that downtown Nashville got hit by 3 tornadoes.
2020?
1998.
Oh.
Yes, 2020 also. That was 2020. But there was a tornado or tornadoes that hit downtown Nashville in April 16th of 98. First time downtown Nashville had taken a direct hit since 1933, and of course it got all the media attention, even the national news. Meanwhile, there's this F5 that's happening in this rural part of Lawrence County that got no notoriety at all. So
Seemed like it hit April 15th tax day, as I recall.
it was the 16th, but
Downtown Nashville.
no, it was the 16th. It was unless the 15th. I forget what day of the.
Tells you how compliant he is with filing his taxes on.
I forget what day of the week.
The 15th may have been
Well, I don't know if this was a Monday. It may have been a Monday. Which, in case it would have been April 16th, would have been tax day that year if it was a Monday. So you may have something here. Most of our tornadoes are EF0, EF1. Fortunately, ignore that one. That's a unknown. That's all those old 19th century storms we don't have an F rating for. So, but most of our tornadoes are small. Fortunately, once we get above EF2, they become exceedingly rare. By the time you get up to EF4, we're talking once a decade. We had one that hit Cookeville, an EF4 that hit Cookeville on that March 2nd and 3rd, 2020. Before that, you have to go back to Murfreesboro in 2009 for an EF4. And before that, Linden out in Perry County, 1999. So it's literally once a decade. They're spaced apart.
What was the rating of the one that actually hit downtown?
Which that was an EF2, I believe. It was EF3. It was the same cell that went literally across all of Middle Tennessee, it hugged I-40 basically. And I think there was EF2 in Nashville, it may have been an EF3 in Mountain Juliet. It was the same cell as the one that hit Cookeville. It was an EF4 out there. But I think it was an EF2 when it came through Nashville.
Took out our West Marine.
EF2s will do quite a bit of damage.
So the numbers, are they correlated to wind velocity?
They are generally, yes. Yeah, they're wind velocity and of course we don't have wind equipment actually measuring the tornado, so we have to look at the damage, certain damage that correlates to specific wind speeds. If you see this, then it correlates to this wind speed. So yeah, it's basically an estimate of wind speed.
So it's like Beaufort scale, basically.
But basically, yes, yeah.
By the way, that April 15 tornado was listed as April 15-16.
Aha.
So it was a 2-day event.
Yeah, well,
But the worst of it was the 16th.
on the 16th. Yeah, in fact,
Final answer.
here it got started early. I mean, like sunrise. So it would have, through the night, it would have been traveling west of here. But yeah, it was a multi-day event. Just hit here on the 16th. But, watch versus warning. We issue watches and we issue warnings. Severe weather watches, severe weather warnings. Watches are issued by the Storm Prediction Center, by the way. We don't issue those. We do issue the warnings here at the local offices. Watch means that the atmosphere has the right ingredients to possibly make severe weather. And that's just a notification to have an action plan, know what to do beforehand if a warning is issued, and then just keep an eye on the weather or an ear on the weather. And then the warning means that severe weather is happening now. We're upgrading from a watch to a warning. That's when you put your action plan into motion. That's the best graphic I've ever seen to explain a watch versus a warning. I did not come up with that. I found it in somebody's slideshow and said, I want that slide for my presentation. So on the left, you got your cake watch, all the ingredients for a cake, but the cake hasn't happened yet. On the right, the cake has happened, so we got a cake warning. So you got watch versus warning.
So Sue should issue me a cake warning next time she bakes.
Yes, cake warning.
One more time, who
It's a cake.
issues the cake, who issues the watch?
The Storm Prediction Center in Norman, Oklahoma issues watches for everybody. At the local office, we issue the warnings.
So they're watching nationwide?
They're watching, yeah.
There's a lot of data analysis. There's not-
They have literally one job, and that's it.
And so are they part of the National Weather Service?
Yeah, they're one of our specialized centers, but they are part of the National Weather Service, yes.
How many people are working there?
I do not know. I've never been there. I don't think it's probably like us. I can't imagine it's that many more people. but I've never actually
They
been.
got computers.
They do
And
big
they have a
ones.
They have a button for the siren.
So how have you seen the accuracy of predictions change over the last decade, and with artificial intelligence, do you see that progressing at?
Oh, I have big plans for AI. But anyway, going back, there's just, and there are charts I've seen that have looked at our, there's just a slow, steady increase. There's no real jump in forecast accuracy, it's just a slow. It's like measured in terms of 30 years ago, our 2-day accuracy, and I'm just pulling numbers, I don't know if this is, but say 30 years ago, our 2-day accuracy would be the same as our 5-day accuracy now. That's a way to look at it. Now AI, I don't know exactly how it's going to come into play. My dream, do we have any baseball aficionados? How are we doing on time? Good.
As much as you need.
Good. So, baseball. I love baseball. And the thing about baseball is they have the best statistics in the world. Now, climate statistics are great, but they're not as great as baseball statistics. So, but sabermetrics and all that kind of stuff, it fascinates me. So you can watch a baseball game, and let's say leadoff runner gets on. And depending on what network you watch, they'll pop up and say, there's a 62% chance that this team will score 1 run this inning, a 24% chance of multiple runs this inning. And I'm thinking, I want that for weather, but how? And I think this is just me fantasizing really. I would hope that AI can recognize patterns in the radar data that can help alert us to tornadoes earlier than what we're alerted to now, that can pick up on patterns or signals that we've never been able to pick up on before. And so what's the tie-in with baseball? I think eventually, and this is more than just me, I think this is really gonna happen, where we can see a certain radar signature and AI will have compiled all this data from all these storms and say, this signature has a 68% chance of producing a tornado, a 16% chance it's going to be EF2 or greater. That's what I'm hoping. That would really help out a lot. Because right now we have
that now?
we do not.
So you're saying extrapolating the data that people have missed, some signature sequence.
All the rotational velocities, those tornadoes do give off a very distinct signature. And radar can also detect tornado debris in the air. We call it a tornado debris signature. So we can look at that with the human eye and know what it is. And we have nomograms to kind of approximate, but it's cumbersome because you got to flip charts and look at all this, and calculate this. And we don't have time for that in a warning scenario because we need decisions like that. And so it is my hope that AI can learn all that on its own. We'll be feeding data into it to be able to pick up on that and give us tornado probabilities. That's just one. There are other ways AI is going to help us out. That's just one that I've come up with first that I'd like to see first and foremost above everything. I don't know if I'll be around for that yet. Hopefully I will. I'm not going anywhere anytime soon. So hopefully it'll be neat to see what AI, what we're able to do. We'll do something with it.
Does the NWS have people working on that right now?
Yeah. Oh yeah. I don't know exactly what all has been accomplished, what all they're looking at. The federal government does not work quickly, although the Weather Service, in terms of the federal behemoth bureaucracy, the Weather Service is pretty quick and reacts really well.
That's good,
I
because
think.
no one needs to know we had a tornado yesterday.
I would assume you have recordings of the radar,
Yeah, it's all that data's everything's archived.
and how far
Is it open
back?
source?
Well, for as long as we've had archive capabilities, it's available through the NCEI, the National Center for Environmental Information, which is in Asheville, North Carolina, which went down. We couldn't communicate with them there for a while after the Helene and the flood, but that's where they're located. They have all that stuff stored there.
So you could go back and look at on specific tornadoes.
You can. You can
or weather
request. You can
events.
request radar archive data.
But it's not just radar. I mean, you guys are
Oh, we've got-
barometric pressure.
We've got all the weather observations, the climate data, the information we get from the weather balloons. We send that to the I mean, as soon as we finish up the flight later on this evening, we'll send it to NCEI for archive. They archive everything.
I mean, there's gotta be telltale signs
There's-
that AI can extrapolate.
There's gotta be. There has to be. And I don't know what all is being done. But my thing is, if I can sit here and think about it, then somebody else has already thought about it and they're already working on it.
Do y'all use any information from independent weather stations?
I look at them. We're like the Wonder Maps.
Yeah,
I love Wonder Map. Now, we're not supposed to officially use them, like put them on our social media, because they're a private company, but I do look at them. And that's most useful for me when we're looking at a potential winter weather scenario, so I can look and see who all is at 32 degrees. Because all the temperatures, not everybody's the same temperature, obviously. So I always like to look at, see where the freezing temperatures are. But yeah, I personally use Wonder Maps, probably more than other people around here. But yeah, that's just one example. Oh, tornado watch versus tornado warning. Watches typically take up a large geographic area, parts of multiple states.
Yeah, we got this. Keep going.
Move. Weather radio. Y'all have a weather radio. Are y'all familiar with weather radio? Fastest way to get your warning. Believe it or not, is still just seconds. Goes directly from one of our software out here directly to the weather radio. It's the same workstation. Just boom, boom, out, signal, send out the alert.
So the VHF transmitter is just right outside here?
Nope, it's at ours. Now there's 12 weather radio transmitters in Middle Tennessee that we program. The Nashville transmitter is located on top of the Tennessee Tower in downtown Nashville. Yes, which is better than if it was out here, because we get some broadcast off that thing. It's a great place to have it. That's just one of 12. There's the 12. Some places have multiple coverage from multiple transmitters. We have almost 100% coverage. There's some spots, especially on the Cumberland Plateau, that don't have reliable weather radio coverage, but it's close to 100%. All right, Middle Tennessee records, all the data from all these weather stations, all these years. The all-time record high in Middle Tennessee is 112 degrees. That occurred in Clarksville on September 7th, 1925, kind of late in the season for that. And then Madison, back when it was a separate town apart from Nashville, they did it in July 29th, 1930. The state record's 113 degrees at Perryville, which is just across the Tennessee River in Decatur County. It's West Tennessee. The all-time record was minus 30 at Kingston Springs in southern Cheatham County. That occurred on January 24th, 1963. Nashville got down to minus 15 that morning. That was the all-time record low until 1985. We broke it again at minus 17. Minus 30, it's hard to believe. I didn't believe that at first, but I checked some surrounding stations and I'm pretty sure it's accurate. That's just, yeah, wow. Most rainfall in one day, it was 20.73 inches. That occurred in McEwen near Waverly. Not too long ago, just 3 summers ago, August 21st, 2021. Now, before that happened, I would not have thought that would be possible outside of a tropical event. This was not a tropical event. That is, I think I'm correct in saying, not just the one-day record for Tennessee, but the one-day record for any state that does not have a coastline. Like you've got some states with coastlines that have had hurricanes that have produced more than that, but as far as landlocked states, that's the one-day record. McEwen, 20.73 inches. It is really.
I mean, what does that equate to in snowfall? What, double the mass?
Well, if you use the typical 10-to-1 ratio, it'd be 200 inches.
10 to 1?
Yeah, typically, and it varies depending how dry the snow is.
Yeah.
10 to 1's a good wet snow. It can be 20, 30, 40 to 1 if it's dry, powdery snow. But
21 inches would cover every hill in McEwen.
most snowfall in one day, 18.7 inches in Riddleton. Does anybody know where Riddleton is? Nobody knows where it's. Riddleton is a tiny. It's still there. It's. I mean, it's the. Riddleton unincorporated, and that's it. They got a sign on the highway. It's near Carthage in Smith County. They measured 18.7 inches on St. Patrick's Day, 1892. Nashville measured 17 inches that day. That's still the record. Has not been touched, even close to. Hopefully, that will never be broken. Okay, we're going to talk about the upper air program, weather balloon launches, and then my part on lake meteorology. Anyway, that's what we're going to launch right there. A small battery-powered device called a radio sonde. We launch them twice a day. Now that we're on standard time, it's 5 a.m. and 5 p.m. If we're a little bit late, that's okay. We just won't get to see it visually because it'll be dark. But I mean, you'll get to see the balloon, but you won't get to watch it very long. We use hydrogen to inflate the balloons. Can use helium. We use hydrogen here, we always have. The balloons usually reach heights of 32 to 35 kilometers. Takes a couple of hours to get up that high. So the ascension rate's usually about 1,000 feet per minute. Eventually the balloon expands as it ascends through the atmosphere. It eventually gets so big that it bursts and it comes back down. The pressure at termination is typically less than 10 millibars, which is less than 1% of the atmospheric pressure at sea level. Not much air when you get up that high. And then the radio sonde has temperature sensor, humidity sensor, and then on board is a GPS, and we can track the GPS and calculate the winds at various levels in the atmosphere.
Is the time of day sensitive? Is there a reason?
Yes, the entire meteorological community around the entire world does their weather balloon launches at 0 GMT and 12 GMT. Now, zero GMT is not till 6 p.m. because it's a 2-hour flight. We issue at 5 p.m. to straddle that 0 GMT. But the entire meteorological community worldwide is synced up to those two times. So that's why we do them at those times.
Worldwide go out?
I'm sorry?
How many worldwide go up at those times?
I do not know. I know that there's 70 upper air stations in the United States. Worldwide, I'd have to say there's probably thousands.
As that device falls, has anybody been hit by it?
Is what now?
As that device falls once it explodes?
Well, it falls, but we attach a parachute so it doesn't fall quickly, and it's very lightweight anyway.
How many of them get returned?
None. We don't take them back anymore. They're all one use only. It is an incredibly wasteful program. Another dream that I have besides AI helping us out with radar is, and we can do this now, and our office specifically is trying to make a push. We have a contract with Southwest Airlines, which flies into and out of B&A all the time. And they have the same equipment on the exterior of their planes that we have. And we get the same data from them that we get from the radio sondes. So we are really trying to get like the higher ups and to use logic and say, we're getting this data from airplanes. Can we use this in lieu of our weather balloons? Because it's costly in terms of the equipment, like the one-time use, and plus.
How do they do wind velocity then? That'd be a hell of a differential.
I know they measure the winds and then subtract out the plane's motion, and you can calculate a wind. It's the same way they do it on ships. They'll go out with a handheld anemometer or have anemometer on ship, and you just subtract out the ship's movement, and you got your wind speed using vectors and all that kind of stuff.
Yeah, but 10 miles an hour to 500 miles an hour is a hard thing to
It works.
subtract down and get the right number.
They've got it nailed pretty
It works. I promise you it works. Because I've compared the two. The aircraft soundings compared to ours, they were very close. I mean, they're not exact, but it's close enough. So we run into the thing, but we've always done that. We have to do this. No, we don't have to do this anymore. So I think this program is on the way out. I really do. I think it's.
Have you seen the ultrasonic wind sensors that they have on the IMOCAs? They have no moving parts.
Yeah, I've heard. I don't know how they work. I know if you count like the vibrations or what or something, but yeah.
No, all these guys have 2 or 3 on every boat.
Yeah. So.
And when you're talking about the airport, when we look at current wind speed on any website, it tends to list the airport, Nashville at B&A
Mhm.
Airport. Do you know, is that your station over there? Do y'all run that station? As far as
That is,
over there?
we own the equipment, we maintain the equipment, the FAA operates it.
Do you know, just for our interest, what the height of that reading is, where their anemometer is?
It's probably, I want to say it's 10 or 12 feet above ground. It's not very far above ground.
You talking about the one at the airport?
Yeah, all of them are like that. The anemometer is just a few feet above, and the wind vane is just a few feet up on a boom.
Which is much higher elevation than Hickory. 'Cause we're down in the gully.
It's as bad as those windows.
You guys want to put one on our
So
flag?
Southwest Airlines the only airline that does
To my knowledge. Yeah. And obviously not all stations have access to data that we have at B&A, but we have it, so we're trying to, it's like, hey, can we like reduce this and not, but anyway, we'll get there eventually. We'll pester them enough. Somebody with common sense will see things our way, so we should do that. I'm sorry?
What does a single launch of the balloon cost?
A lot,
75.
too much. About $300 when you count the instrument, hydrogen, the manpower. They're expensive and they're wasteful, and they're not good for the environment because you got all these burst pop balloons lying all over the place, and they're not biodegradable. That I think made of latex. I don't think they're biodegradable. So I would love to stop doing them. I love the data. Don't get me wrong. We get it's not like we're getting the data from somewhere else. We're not losing anything. But anyway, that's the inflation building that you saw at the top of the hill, and inside all our tanks of compressed hydrogen, and there's the balloon and parachute and the radiosonde, and then when the balloon's fully, you'll see that. You're going to see it. And then right before launch and then after launch on a clear blue sky. We're not going to get to see that today. It'll be dark, so we get to see it.
Light in it?
No, I'm sorry?
Put a LED in there.
We actually used to tie a light to it when we had to manually lock onto the signal and point the antenna at it, but it's all done automatically now, so we don't use a light. We used to do that though. And then the data gets fed into a PC out in operations, and we get to watch the data come in almost live. It takes a few seconds to post-process the data, but we get to see it almost live. That's a skew T. I'm not going to belabor that because it looks horrible, I know, but it's just a graph of the plotted temperature curve with height and the plotted dew point curve with height, and then there's a hodograph, which is all your wind vectors at various levels. From that, we can calculate all kinds of various parameters, severe weather parameters, tornado parameters, winter weather parameters, all kinds of stuff we can tell from that. Okay, lake effect weather, we're good. Okay, y'all know what lake breezes and land breezes are.
We're trying to figure that out.
We're going to start. We're going to start. We're building blocks here. We're going to lay down the first, and we're going to build on top of that. So y'all, you get rising air over land during the day, creates low pressure. Land heats up faster than water, obviously, so you get rising air over land, sinking air over the water because it's cooler during the day, and you get this current. So because you get high pressure over the water during the day, air blows from high to low pressure. So it's going to blow from the water to land. It's called a lake breeze or a sea breeze, same concept, water versus land. And then the inverse happens at night because the land cools off faster than the water, obviously. Well, now you get low pressure over water, high pressure over land, because when you cool air, it creates high pressure sinking air. When you warm something, it creates low pressure rising air. So now, all of a sudden, the breeze shifts, and you get land breeze because you got high pressure over land, air blows from high pressure to low pressure, so you get wind in the opposite direction from land over the sea. And this is what we call microscale effects, very small scale, very localized effects, especially over a lake like Old Hickory Lake. It's not like one of the Great Lakes or anything, it's smaller. And so, and we don't have any equipment anywhere to measure it. I would love to know I would love to have like a buoy out there somewhere with an anemometer, know what the wind speed is, because I know wind, well, we get to this in a slide in just a minute.
Well, you see, it's never stable anywhere.
$3 more a person.
There you go.
It won't cost that much, I wouldn't think.
We can take up a conversation tonight.
I love coming down the hill, Saundersville Road, seeing the steam fog and it happens most often during the autumn season. That happen any time of the year, but
Playing
but
Jimi Hendrix.
do what now?
Playing Jimi Hendrix.
Yes.
Smoke on the wall.
Exactly, purple haze, and
Yeah.
can you see somebody out there on a boat early morning through the fog? Oh, somebody's out there fishing already. Steam fog. I love the name too, steam fog. Forms mainly during the autumn season. As summer ends, water temperatures don't cool as quickly as the air temperature does. So you got relatively warm water, cool land temperatures. So as a mass of dry, cold air moves over a warmer lake, the warm lake conducts warm, moist air to the air mass above. Water vapor cools, condenses into liquid water droplets, and you get steam fog. It's a beautiful phenomenon. I love it. It's one of my favorites. One of my favorite things about working near Old Hickory Lake is you get to see that a lot. Okay, why are winds over water typically faster than over land? Well, duh. Water typically has a smooth surface. Again, I would love to have one of those. That's not Old Hickory Lake, obviously. So I would love to have that out here just to know what the winds are doing, or how much faster it is. And I don't know, I don't have an answer. I don't know how much faster the wind goes over the water out here than when it comes in over land.
Not much.
Is it? There's got to be some. There's got to be some difference. There's got to be some kind of.
Do it.
So, Mark, where would you want to put it and how high above the water?
Will you give us the equipment? We'll install it. at
I
the
would.
club.
I would love to have several.
Yeah.
And I would like
Maintain it
to.
in our harbor on the water. when you give it to
I
us.
would like to know what not just the wind speed. I'd like to see what the wind direction does too. That would be fascinating to see all of it. Because we
Oh, we can tell you that.
It's random.
we have all these land stations where the wind direction is usually from a consistent direction. But
We have a name for the lake, it's called Old Trickery.
okay. So Brian asked me the.
Seriously, going back to that, we're all serious about trying to put those monitors in. So if you could give us some counsel
Yeah.
on how to do that, well, I think we.
I honestly don't know. I've never been associated with any. I've always
You have a guy,
I've always
right?
dealt with. Do what now?
You have a guy that does this, right?
I don't know. A guide.
Might be a
Person.
Oh, God.
It might be.
Not for lakes. We have ocean services.
Do you have an email?
I wouldn't know how to. I don't know of any. I mean, I know they exist. I don't know. I don't know that the Weather Service does them. It's some other entity may do them, but we just don't. We don't put in. I know it sounds
We
weird,
got
but
an old piece of dock,
yeah.
and we'll put one of your weather stations on that and haul it out there in the harbor.
Just leave it in the middle of the lake.
But all of the weather stations are the automated stations that we put in at airports. That's it. That's all we do. We don't put them over water. I wish we did. I would love to. Again, it would be fascinating to see all the little local effects and what happens to the wind directions. But
That's one way to beat AI.
so Brian, I remembered the question. I think I don't remember exactly how you phrased it, but I remember the concept. How do I know if a wind maximum is headed toward the lake? You talked about a situation. Do you care to elaborate just to kind of set the table?
So, I'd say Bruce is sitting down there. He's the one that created that wonderful missive that kind of described what happened. But during the lots of lasers, we literally were sitting there staring at our phones, which now I understand that the radar that we get is a lagging indicator. But we watched a storm literally spin up above our heads. And then when it started, we had this really long-lasting downburst of probably 30 or 40 miles an hour at periods that just kept going, which for us is pretty unusual. Normally these gust lines move through pretty quick, and this one just hung on for a while. It felt really unusual to all of us that were out there.
When was this?
September 21st. Wow.
Yeah.
I got nervous. There were kids out there.
Yeah.
Like it was not on our radar at all.
It may not have been a downburst. It may have been something called a wake low, which happens behind thunderstorms once a thunderstorm complex
That makes
passes.
sense. A thunderstorm passed us.
Yes.
We watched it pass.
Right.
And as I headed down the lake, it looked like it passed.
Right.
And all of a sudden, boom,
That sounds like a wake low,
wake low.
which is a localized center of low pressure that occurs in the wake of a departing storm, or usually a line of thunderstorms. What happens is you'll have high pressure because air literally piles up ahead of the thunderstorm. And downbursts create high pressure because it's air descending. When air descends and hits the surface, it creates high pressure. Well, what goes up must come down, so that air that comes down has to come from somewhere. It comes from behind the thunderstorm complex.
Perfect.
So when air rises, it creates low pressure, creates a wake low. When you get low pressure, the deeper the low, the faster the winds, because the larger the pressure differential with the surrounding environment, the faster the winds, because air's trying to equalize itself. Like imagine if you were to suddenly open an aircraft window at cruising altitude, you're going to have this massive outrush of air because the pressure differential is so great between inside the cabin and outside the cabin. Well, the same thing happens at the surface. The larger, the deeper the low pressure, the larger the differential with the surrounding environment, the faster the winds. So what you described sounds like a wake low. We had a massive wake. I don't remember, it may have been the same one. It's been a little while, but we had to actually issue a high wind warning because the winds in the wake low were so strong, they were actually causing damage. I mean, like 50 to 60 mile per hour. For again, like a sustained, it wasn't just an instant downburst and then gone. It was wind sustained over a fairly long period. So
This was 30 to 45 minutes.
yeah, that sounds like a wake low. Downbursts aren't going to last that long.
Bruce, did the wind not shift 180 degrees as it hit?
Well, the wake low was from one direction. It was from the storm direction.
Right.
Blowing
And it was
directly
from
in
the
our
storm
face.
direction, it was.
Yep.
It's coming
So
right in
coming
our
from the
face.
north.
That makes sense.
So the question that Brian asked was, how do I tell
Yeah.
winds? And the best answer I can come up with in absence of a network of anemometers is your radar velocity profile, which again, it's not surface, but it's the best solution that I can come up with, That is just a sample from an app called Radar Scope. It is a paid app. It costs $10 for one-time download. I've got it. We all have it. That's the National Weather Service radar there, and you can get your reflectivity, but then you can also get velocity, which there's not much velocity now because there's no precipitation or anything out there. There's a few speckles of velocity.
Radar scope?
Called Radar Scope. Now there are other apps. I think like Weather Channel, maybe AccuWeather have apps that have access to free radar data that I think probably includes velocity data. You can look into those as well, but that's the best way I can come up with to tell if a wind maximum is headed toward the lake. Other than the fact that if we've got a warning out, then you'll know, okay, wind maximum is headed toward the lake.
And what would a wind maximum look like?
These very bright colors, and there's a scale that.
And can you tell anything about the direction that
Yeah.
they're moving?
Basically, the velocities in green are wind moving toward the radar. There's the radar up there. Velocities in red are wind moving away from the radar. So what you have here is a storm that actually has some rotation. You got wind doing that and wind doing that. So there's actually some clockwise. It's not tornadic, but there's some rotation there. So
Is that a hook we're seeing there?
no, it's not.
That's a reverse, isn't it?
Yeah, it's the reverse. But I was looking around the other day for a good velocity image, and we didn't have anything because there was nothing going on here. So I found Mobile's. I was like, oh, Mobile's got some storms. I'll look at theirs. So that's what a velocity image looks like. You can see your little wind maxima there where the brighter colors are. But that's how you interpret velocity data.
So on that day, it was not showing on WKRN's radar, there wasn't anything showing as, I mean, we weren't using that app, but there was nothing showing on radar.
There may have been an absence of echoes because, again, this is in the post-storm air mass. And so in that case, you're not going to, it's not a fail-safe method.
It showed up on my app.
Yeah.
It was clear until it
Yeah.
wasn't. So how far away or how close might a storm be for a wake low to be relevant to where you are?
Right after it passes. Right after
Is it a
the.
mile away, 8 miles away?
Uh,
Right behind us?
Yeah, I think in this case there was a gap of several miles because it kind of caught us by surprise. It really, we didn't, I mean, now every storm complex is going to have a wake low just by nature. Most of them aren't consequential. This one was rare. 99% of them are not as strong as this one. So not to the point that we're issuing high wind warnings for it. You'll have some gusty winds post storm. That's the wake low. Again, they all happen.
I mean, I suspect it was 2 to 3 miles.
but
I mean,
there-
it's not like it was over Gallatin.
Right, and there may be a few mile gap in there before the wake low gets going. So yeah.
Is there I understand that your radar, like you were saying, downtown Nashville versus looking at Clarksville because of how up.
Right.
How about as far as being in close to the weather ball? I mean, how close can you see stuff that makes sense? Because I know when I see the regular radar thing, it shows, and you
Right.
can see it's basically the one from the
Well,
weather.
there's a cone of silence like right here at the site.
How far out is that?
It's just not a couple mile or two. It's not very far.
A couple of miles,
Yeah,
a mile or
yeah.
two?
Now there is a caveat. There is a Doppler radar in Nolansville with that shows up on the Radar Scope app. It's the FAA's radar. So for storms that are like affect here, we'll look at the Nolansville radar. It's not a Weather Service radar. It belongs to the FAA. It's called a TDWR, Terminal Doppler Weather Radar, but it's in Nolansville. We use it for storms that are close in. So we're not like totally in the dark for storms that are going to hit the office. So we'll look at that one. So there is a radar out there that will help with Old Hickory Lake.
Boy, that's ironic. I mean, we've always thought that you knew what the weather would be here and on our lake, and what I'm hearing is that you actually have to rely on data from a different
Exactly.
radar thing because of.
Right.
I understand that.
Yeah.
So how do you overlay both of those so you can kind of take out that cone of silence? Is there...
We have this nifty feature called MRMS, called multi-radar, multi-sensor, that will actually take radar data from multiple radars and mesh them together into one single product.
Right.
It's great.
So how do we get that?
You don't. I don't think.
How do we monetize this?
I don't think it's available. Hang on.
Come on, Mark, inside deal.
No, I need to double check. I need to make sure I'm right about this because I don't want to.
Well, National Weather Service radar.
Nope. Unfortunately, that is an in-house product. A lot of the stuff we look at is in-house. And there's a lot of data on radar scope. Unfortunately, the multi-radar, multi-sensor is not one of them. Maybe one of those things in the future. I don't know if there's plans to do that or not. I would love to have it because we use that for like radar for rainfall estimates and all kinds of stuff. But yes.
Now, when we're looking at radar on our apps that we have, I've got 3 on my phone, and the day they're talking about, all 3 apps had different radar pictures.
Mm-hmm.
Where are they getting their radar from? Because they were all very.
They process the their radar, and I don't know how they do it all.
Because I always assumed it was coming from.
Yeah,
it's
it's all the post processing and formatting of the image. This is the radar scope is the most authentic. That's exactly what we have here. There's no processing done with that. I don't know what all those other companies. I'm not sure how they process their data, or how they come up with that, or if it's our radar or TV stations' radars. I would think it's our radars, but I'm not for certain.
One was Channel 2, and
Yeah.
then AccuWeather, and the Weather Channel. And
Yeah.
they're all 3 different.
Yes.
Where the line of writing
Yes,
is.
I honestly don't know how some of those private
On a regular
companies
basis.
process their data.
We're gonna miss the launch.
No, we're not. Because it relies on me. I'm the one doing it. So if it's not right at 5, it's okay. We have a window. And if it's not at 5, I know it's 5:01 now. But
We'll just have to gas it up a little bit more.
no, it's pretty tight. I tied it off. You can tie those things off and leave them for hours, and they're still inflated.
Really?
Yeah, I do.
Anybody else?
No, thank you. That was.
Yeah, that's good stuff.
Absolutely.
Very enlightening.
Do you need help up? Do you need a hand?
Well, we'll see.
All right. If you don't mind, we're going to go out there and we're going to do a quick tour of operations.
see how well my orthopedist knee injection yesterday worked.
Thank you.
Thank you so much.
Satellites and things like that.